Hello, welcome everybody. Um, so we're here for the data visualization seminar, and we're going to be using Paraview to do so. Um, did anybody still need to download Paraview? You can unmute yourself, or you can type in the chat. All right. So this is going to be fairly interactive. I'm going to make you do most of the work. So you are going to need Paraview and the data files. So the slides you can download from yarn.ca/vis.zip. It should have been in the email that I sent out yesterday. And so yeah, let's get started. So for visualization, there are many different tools. You can use different programs like Paraview, Visit, Mathematica also has excellent plotting. Python has a whole bunch of plotting libraries as well, like matplotlib. R has ggplot. There's so many ways to plot data, so we have to pick one. And we're going to use Paraview. And I chose Paraview because I'm the most familiar with it. And it's also a great package for making 3D animations and yeah, handling 3D data. It does 2D data as well, but its main focus is on 3D data. 3D data. So Paraview is very elaborate. It's been around for at least a decade, I think, and it can handle almost any data format that you can throw at it. So if you have a package that you use, a specific program, and it outputs data in a certain format, it's highly likely that Paraview already knows how to deal with it. It also comes with Python scripting integrated it. That means that you can easily extend Paraview or you can work on the data inside of Paraview, so you can process it on the fly. And like I said, it can create great 3D animations. It also supports remote rendering, and what it means is that it uses the client-server model. So Paraview will run on your computer, and then you have a rendering server that runs on another machine that has a lot more memory than your own machine, for instance. It's very popular to use this with Compute Canada, so you reserve a few dozens of CPUs or a GPU if you want, and then you can offload your rendering on that machine while you do everything, the rotating, all that on your own machine. So it's really a powerful tool. And the design philosophy for Paraview is that everything goes through a pipeline. So I have a picture on the right where a data file is loaded. So here we have PV in C2 and then the resolution. That's just the name of the data file. And then we have another thing that we attach to it. And in this case, it's a clip. I'll get to the meanings of these filters later. I just want to show you how the pipeline works. So the clip works on the data and it takes a piece of the data. And then on that piece of the data, we apply a contour and a calculator. And then on the calculator, we apply one slice and another slice. So you can see that all of the filters have input and output, and they can pass along information to the other ones. So you can build these complex rendering pipelines. So this is the user interface. So on the top left, we have the most common filters. So these are buttons you can click and they apply automatically on the data that you've selected in the pipeline browser, which is right underneath it. So currently no data is loaded, so you don't see anything in here. Below we have the inspector, and the inspector is where you set all the properties for your filters. So if you have like a slice through your data, in the inspector is where you would set the coordinates of the slice. So is it slice in the vertical direction, horizontal direction, or in the depth? And you can change the color palette, all these things. And then on the right, we have the render view, and that's where your actual uh, image is going to be projected. We have some more tools that apply to the render view, so we can turn on 2D and 3D. With 3D, you get 3D rendering, so your mouse acts as a device for rotating it. If you set this to 2D, you just get a flat surface and you don't get any rotation, so that's useful for working on 2D data. The other ones are of less interest. It's for identifying points, which we won't be doing here. But the ones on the right are useful. They are for splitting. So if you click this one, it will split the render view in two horizontally. So we'll get one on the left and one on the right. This one does the same thing, but does it vertically. So you can have different subviews of the data simultaneously on the screen. Then we have the buttons over here. This one, it zooms to the data. So what it does is if you lose your way and like your data moves out of the screen and you can't find it anymore, you can click on that one and it will center back on your data set and you can see it again. These buttons are helpful orientation. So they project the data in certain ways and you can rotate it. So I'll just open Paraview on my computer. So this is what the Paraview looks like. I'm running 5.8. I think I told you to download 5.8.1, but it's pretty much the same thing. So in the top we have different menu items. One of them is sources. And sources are, well, sources of data that you can use to make the data more vivid. For instance, you can put in a cylinder and then you press apply, and then your cylinder appears in the rendering view. You can see it's not a very great cylinder. It's more like a hexagonal cylinder. So the resolution is really low. But then when you look in the inspector, you can see that you can change the resolution. So if I increase that a bit and I press apply, now it's going to be a proper cylinder. And you can see that Paraview takes care of the shading, so you can really see that this is a 3D item, even though it's not colored in at all. So about coloring, that's also in inspector. So currently we just have solid color, but later on when we are going to load data sets, these will also be whatever is in your data, so like pressure or temperature or whatever. And if you click on edit, you can change the color of these things. And now you have an orange cylinder. And like I said, you can split the view, create a new render view, and then we can add something else. We can add a cone, apply, and again the resolution is not great, so we can increase it, apply, and now we have a nice cone here. And we can again change the color. I can make it pink. And you'll notice that there's a slight blue selection triangle over this view. So that means that that's the view I've currently selected. And when you look in the pipeline browser, you can see a little eye symbol. So when the eye is open, it means it's visible. When the eye is closed, it means it's not visible. So you can click on that to turn it on and off. You can also show them both in the same figure. And then when you click on the other view, you can see the pipeline browser changes. And then this view, you can subdivide again in another render view. And you can show your cylinder here, but from another angle or with a different color. So those are all the things that you can change around. Oops. So that brings us to the first exercise. So I want you to open Paraview. And I want you to try to recreate the figure I have here on the screen. So I have a cylinder on the left and then a cube, and then on the bottom right I have a cube and a cone. And you can see that in the pipeline browser here on the left. So I'll give you 2 minutes, or no, I'll give you 4 minutes to try that out for yourself. And if you have any problems, feel free to unmute yourself or to you can also type it in the chat if you want. So we'll go at 9:16. Yeah, and also let me know if you have any trouble getting Paraview to run, of course. I can help you with that as well.
Just a question. It's when I try to open it, okay, there is a window defender or whatever there is that says that it's unknown or when I install it, okay, there was a bug as well, or the computer has some security, and then so it says and now when I'm trying to open it, they gave me a warning as well, okay, that do you trust or something this. So is there a problem with this, or can I trust opening it? Yes.
You can
And it
trust
is
it. I
yeah, so
mean,
it is the PV. It is the PV, yes?
yeah, that's correct.
It's called PV Server 5.1 server. Is it
Yeah.
the one?
So yeah, Paraview consists of two programs. There's the client, which is Paraview, and then there's a server,
Yes.
which is PV server, like you mentioned. So they,
Okay, so it opens to a window. It says waiting for clients connection URL, accepting connection, and etc. So I'm not sure.
oh, um, so that happens when you open Paraview immediately, like you haven't clicked on anything yet.
Yeah, I just go open it and it says P server at the top 5.8.1 server. It says waiting for clients, connection URL, CS, etc., accepting connection, and now
Okay.
it's waiting.
Yes, I think you may have opened the wrong program. There should also be something called Paraview instead of PV
Okay,
server.
okay,
You can
I'll
close the
try.
PV server, by the way.
Yes. And the other one that I have is the PV P render server 5.1 render server, or I have PV Python
Oh,
shell.
that's strange. That should be Paraview. Um, let's see if I go to.
Because I downloaded the 5.8.1 and I just executed. In fact, yes.
Let's see. Yeah, there's a whole bunch of options.
Yeah, there was an exec one or
Yeah,
something.
exactly.
Yes.
So
Sorry, can I make a suggestion?
yeah.
You're running in Windows.
Yes.
So in Windows, when I had it, I click the start menu and it shows recently added. It shows three options, but if you click the button below that it says expand, then it has two more options that are recently added. And Paraview 5.8.1 is one of them with a different logo with three stripes, red, green, and blue. You can also
Yeah.
scroll down the start menu to find it.
Well, okay, fine. I'll follow along. Okay, so no problem. I don't want to take too much of your time, but I will
Yeah.
try to solve it all. Thank you.
Yeah, I mean, this is a very interactive one, so if you don't have Paraview, that's going to be a bit of a problem.
Yes. Well.
Um, yeah. Yeah, I mean, that should have been a link that worked. Like, you can press start and you can try typing Paraview, and it should pop up. So if you press start
Okay.
in Paraview, I mean, this is Linux, but it should be similar on Windows. Yeah, but I'll continue in the meantime.
Yes, yes.
Okay. So is everybody able to successfully get this image that oh, where's my slide? This image here. So this was just an exercise to get you a bit familiar with how Paraview works and where all the buttons are. Oh, and I forgot to say one thing. I'm recording this session, so if you have any objections to that, you can let me know, and I'll cut out anything that is related to you. Okay. So that's a bit about how the interface works. And one of the big things that Paraview does really, really well is the reading data part. So I tried to count it, but there's more than 160 file formats that it supports, so I lost count. Some notable formats that occur very often are VTK. So VTK is the default file format for Paraview. It's what it uses internally. And it comes as various libraries for your program. So if you program in C or C++, there's a library for it. If you program in Python, there's a library for it. It's an open format, so if you have some other programming language, there's highly likely there's a plugin for it that you can export to VDK. Another one is H5 in combination with XDMF. So H5 is a format that's specifically geared to scientific data, so it can support different structures, different um, how do I say, different fields. So you can have pressure and temperature, all that stuff in one file. And I say in combination with XDMF because XDMF is an XML file that describes what's inside of the H5 file. There's also the very well-known CSV file, which is the comma-separated values. You can export those with Excel and a whole bunch of other programs to export in CSV as well. And of course, there's the raw binary format. So especially if you have your own program and you just dump the memory to a file, then they can also be read by Paraview, which is very handy. So as a simple exercise, I ask you to download vis.zip, and it has a subdirectory called data, and there's a bunch of data files in there. So let me just open the workshop. So it should look like this. And then we have simple data raw and simple data XMF. And we're going to try to load simple data.xmf. So we go back to Paraview. You can reset this thing if you click the reset button over here. If you click reset session, everything is gone and the data is gone. And then you can use file open, or you can click the button here, which is also open. And then you can navigate to wherever you stored the data. All the files should be there. And you can try opening simpledata.xmf with the reader S. And one thing I should mention, every time that you load data, you have to click on apply. And you should get an empty box like that. So here are the instructions for that. So the data is a bit of fake data. It's basically this formula at the bottom here. Yeah, so the idea is a bit to play with the various options. So here we have solid color, and now you see you have density here. And you can change outline to volume, and you get a sort of transparent view. You can change it to surface, then you get the surface of the cube. You can take points, then you get the actual data points. You can also use point Gaussian, then you get the actual data points, but are just a bit bigger. So yeah, just try it out a bit. You can also change the colors with this in the inspector. You may have to scroll down a bit if your screen is not big enough, but you can press under coloring the little heart symbol and you can change it to different colors. Uh, yeah, so any questions about that? Yeah, so you can really see that Paraview is quite powerful. So it can read the data and it instantly shows it. You can rotate around and you can even look inside of it for a certain amount. Later on, we'll get to use the filters and then you can really cut down into the data and try to make nice visualizations out of it. So the simple data.xmf, it's an XDMF file. So that's something I mentioned before in relation to the H5, but it also works with binary files. So this is what it looks like. It looks kind of horrible in XML, um, but it describes the data. So we have the simple data.raw. And if you look back in the files that you downloaded, we have a simple data.raw and a simple data.xmf. So simple data.raw, it is raw binary data. So I wrote out the data, and here in XML, I describe what the data means. I can make it a bit bigger if I open the file. Let's open that in Atom. So that's my XMF file. So I'm saying my data contains a uniform grid, 16 by 16 by 16. Origin is at 111, and the spacing, the dx, ydz is also 111. And then I have my binary file data, which is 16 by 16 by 16, and I say that the data are floats. So that means 4 bytes per data item. And the name of it is called density. So when I compare that to Paraview, that corresponds to this data entry here, density. Yeah, also here. So this is the same thing. So just not to confuse you there. So this is useful if you have a program that you already have that outputs binary data because you have the full control over the source code. And then you can easily make it compatible with Paraview just by also outputting a file like this. And I've put a link in here that describes how to create these files. You don't have to do it. You can load the binary data directly into Paraview as well, but it's not the most easy thing to do. I'll show you. So if I open the raw, and I have to use the image reader because it's a binary image, then it's going to ask me all of these questions, like the data origin, data spacing, the data order. So I had a float, like little endian, I think, and you have to put in a name yourself. It's a three-dimensional file. Data extent goes from goes from 1 to 16, 1 to 16, 1 to 16. So you have to do it every time that you load the file, which is, oh, and if you make a mistake, then Paraview crashes. I'll just start Paraview again. So yeah, that demonstrates it. You really want to use an XML file if you're handling raw binary data. So now we have some data loaded. We can try using the filters. There are a whole bunch of them. This is the bar that you have on the top of your render view, top left, sorry. You have the calculator, you have the contour. This is clip, that is slice. This is a threshold, so you can cut down certain values below which you don't want to see anything or above which you don't want to see anything. This one is the glyph, so that allows you to assign 3D symbols to points. The stream tracer lets you visualize vector fields, so it shows you how a particle would flow through the vector fields. This is warp by scalar. It's useful for transforming 2D data to 3D data. The others I won't get into. They are used less frequent. There are many, many, many more filters than just those two. In the menu option filter, if you look at alphabetical, you'll get this giant list of all the filters that can be applied to the current selected data. You'll notice that some are in black font and some are in the gray font. And that means that the black ones can apply to the currently selected data and the gray ones cannot. So that goes back to how you load the data, because some data you load it point by point, so you have like a grid that has equal distance. But that's not the only way you can put data. You can also have random points all over the place that represent your particles, and then other filters apply. So which filters apply, it kind of depends on what the structure of your data is. So I'll show that in Paraview. I need to load my data again. I'll use the XML file because obviously reading a binary file is difficult. And I always have to remember to press apply. So let's get the volume back. Actually, no, let's get the surface, because then it's easier to show things with the filters. I don't need that, just to make it some bigger. Right, filters. So here in the menu entry, you have filters. So you can get alphabetical. That will get you all of them. There are also some subcategories that narrow it down a bit. Another way is to use these buttons here. So those are the presets that I mentioned before. And yet another way is you can right click on the data and add filter. And then you notice that the alphabetical list is a lot smaller now. And that's because now it's only showing you the ones that are applicable to this data. So this is actually one of my favorites. So right clicking, add filter, alphabetical, and will only show me what applies. So that's nice. Then another one is if you hold Control and you press space, you get this thing, which allows you to type the name. So I can type slice, and it automatically finds all the ones that start with, well, I typed SLI here, so between the brackets it shows you what you typed, and then it finds all the filters that have SLI in them, and then you can click on it, and it gets applied. Sorry, it gets drawn, not yet applied. If you want to get it applied, you have to click on apply. And I think the first filter we're going to play with is going to be this. Oh, right. This is just a repeat of what I mentioned before with the pipeline filter. So you have multiple filters that work on the data, but filters can also work on filters themselves. So you could slice something and then you could do another operation, like you can slice it again or whatever you want. You can chain them together like that. So now you can just try to play with it. We use the simple data.xmf again that you probably still have opened. And you can try the slice and the clip and the contour, and you can also try changing the colors. So you select the data, and then you can select contour, you can select clip, you can select slice. So if you select clip, you press apply, you'll notice that it changes it. You can move this around, apply, you can move it around, apply. You can also select the arrow here, and then you can move the orientation, apply. And you can select the date again, and then slice. You get another one like that, but this time if you press apply, you just get the slice and not the clip. Using the eye symbols, you can turn them on and off as you want. The contour one is here. The contour one applies to the slice because I clicked on slice. I don't want that, so I click on delete. I select my data again, contour, and then it automatically picks the in-between value, so you can press apply, and you get your contour filter. And below here, you have the little heart symbol. Then you can change different colors. Yeah, so just try that out for a bit. That will get you used to using filters. And make sure you have selected whatever you want to apply the filter to. So I'll give you 5 minutes for that. So we'll go at 9:39.
So yeah, now can you restate the way you got the little pop-up window where you could type in and do a search for different filters?
Yeah, so that's you hold Control and then space.
Okay, thank you.
I think for Macs it might be Command and then space. It's also under Filter Search, so the shortcut should be there already.
Sorry, I'm having an issue with just loading the data with Paraview because each time that I switch it to the density view, my entire program just kind of crashes.
Oh. Okay. What system are you on? Is that Windows or?
Yeah, I'm on Windows 10.
Okay. Can you try another one? So if you click File, Open, and try can.ext2. Oh, I should reset.
Oh, that one crashes as soon as I load it.
Oh. That's a problem.
I'll maybe try reinstalling Paraview.
Yeah. It might also be the graphics card drivers, but that shouldn't really be much of a problem these days anymore. I don't suppose you have another computer around.
Only my husband's, and I don't have the passwords.
Okay. Yeah, I mean, it just crashes. It doesn't show you an error at all, right?
No, and like it doesn't completely crash. It's almost like the resolution on it just goes crazy.
Hmm. Yeah, that kind of sounds like an issue with the drivers for the graphics card. Like this is a 3D program, so it needs access.
All right,
Yeah, fun stuff,
I'll
but yeah, sorry.
okay. Thanks anyway. I'll
Yeah,
see what I can do.
yeah. And this is all recorded, so you can watch it later again when things work, I suppose. And yeah, and afterwards I can help you diagnose this as well, of course.
Perfect.
Excuse me.
Yeah,
Will the video be available later on for us to practice offline?
yeah, yeah. I'll put it on our website where I put all the videos so far. I'll send you the link afterwards.
Okay. Do you have our email addresses and all?
Yeah, you registered for this workshop, so I have
Okay.
all the email addresses.
All right. Thank you very much.
Thank you. Oh, I see some people typed in the chat. Sorry that that chat isn't that visible all the time. Oh yeah, that's Julia's questions about the crashing. Chris, can Paraview generate the XML file from information that you just input? No, it cannot. Yeah, you have to generate it yourself. That's kind of annoying, I guess. But you only have to do it once in your program and then it's automatically generated for you. Yeah, so that's basically how you add all these filters. And you can see in the pipeline browser that you have simple data XMF and clip one applies to simple data, slice applies to simple data, contour applies to simple data. But I could also, let's just remove a few. And I'll just keep my clip, which cuts it in half like this. And then on that clip, I can apply like a slice. And then I have my clip that's also a slice. So instead of the full clip of the entire data, um, I just get a slice of the clip. You can follow the lines here. You can see the pipeline is simple data, clip, slice. So the other data that we can load is CSV data. So CSV data is, well, almost any program can support it. But I would not recommend using this if your data set is large. If you have a large data set, it's much, much better to use binary because text data is probably around a factor of 8 or 10 times larger than it really needs to be. Um, so I have another text file, sorry, another file in the data called volume.csv. And I can open it in a text editor. And you can see it's text. So these are the column names, X, Y, Z, and then F1, F2. And then I have all these comma separated values. And it goes on and 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 on. So I think it's 100 by 100 by 100, if I remember correctly. No, it's less than that. 20 by 20 by 20, I suppose. Anyway, this is a CSV file, and many programs allow you to export that. And to load it in Paraview, you have to do some trick. Because when you load a CSV file in Paraview, it only knows it's a collection of points. It doesn't know that it can represent a dense volume. So first we have to apply a table to point filter. So that reads the CSV file. Sorry, it takes the spreadsheet data and it changes it into points. Because by default, Paraview doesn't know that the x column corresponds to the x coordinate. or any other column. And then we have to use the Delaunay 3D filter to connect all the points to make it into a solid object. Yeah, so that's my exercise. I'll just show you that. I'll reset. So I'll reset the session. Everything is blank again. I will open the data. I have my volume.csv. And I want to use the CSV reader because it's a CSV data. Paraview always tries to guess what the reader should be based on the extension, but sometimes multiple programs use the same extension for different files. So that's why it's always asking you which reader it should use. And then I press apply. And now you notice that it loads the spreadsheet data. But you don't see anything in here at all. You don't even get the option to show it. So first you have to apply a filter. Table to points. And then I have to say what the X, Y, and Z column are. So X column is X, Y column is Y, Z column is Z. Apply. And you notice that you get now points magnitude, and it changes a bit. And then I select the render view. And now I have an eye symbol, and I can open it, and I get all my points. But you notice it's still set to surface, and it's not really surface, they're points. So Paraview doesn't understand yet that this is actually a dense object. So the other filter that we need to apply is the Delaunay 3D. And we can keep the standard settings. And now we have a solid object. And also we have the two data fields F1 and F2, which are the only two columns that are not related to the data. So we can select those. And now we can apply our contour filter and all that stuff. And we can close this spreadsheet thing here using the X. And then we have the big view again. So you can try that as well. I want you to recreate this egg-like thing using the instructions I just showed you, how to load the CSV data. And I'm rotating it here automatically because it's a 3D figure. It's a bit hard to show if you're not moving it around. And the hint is that you should use the contour filter. So try to get it as close as possible to this egg thing as you can.
Hi, sir. I have a question.
Yep.
Yeah, I just accidentally closed my data, the table of data for the volume CSV file.
Hmm?
How to get it back?
Oh, yeah. So you can load it. So when you say you lost it, is it still
Yeah,
on the left?
I closed the window to show the table of the volume file.
Okay. So yeah, so you can open the file again.
Okay. Open it again.
Yeah, and then you can choose the CSV reader, and then it's table to point and the Lonely 3D.
No, I mean if I close the window that render the view
Oh,
of the table.
sorry, I know what you mean now. So you
Oh yeah.
click this button here. So you have
Yeah.
you're in this screen now.
Yes,
Oh yeah, you
exactly.
can click a render view,
Yes.
and then on the
But it
left
doesn't.
you
Okay.
can click the eye symbols to make it show up again.
Yeah, but I want to see the table that contains the data.
Oh, then you can yeah, you can close this. Yeah, there's multiple ways of doing it. I'm going
Okay.
to split the screen, and then I'm going to choose spreadsheet view,
Oh yeah.
and then I can see the spreadsheet. So volume.csv is the original file that we loaded, and after we apply table to points, we have a point that's 3D.
Oh, I see. Oh, thank you.
Sure. Yeah. Okay. So did anybody had trouble finding the egg? Yeah. So. Oh yeah.
Sorry, for me, it shows just a line, a dot line instead of the volume. When I applied the table to point filter.
Okay. So you have this thing with the points, or
No, just a line.
like this.
It's not a volume. It's
Oh.
just a simple line.
Oh, really a simple line. Okay, sorry. Yeah, would you like to share your screen? Keep in mind that it's being recorded. I'll just stop sharing my screen so you can share yours. And then I need to, let's see, where are you? Oh, there you are. Make a presenter, change. Yeah, you should be able to share your screen now.
No, it says only meeting organizer and presenter can share.
Oh, sorry.
No.
Yeah, I see you're logged in twice.
So yeah, this is what I get.
Okay, so you're at the table 2 points. Okay, so in the properties, it says X column, Y column, and Z column. So you set the X column, Y column, and Z column to all to the F1. So it's saying that the X coordinate is F1, the Y column is F1, etc. So that's why you get a line. It's only using the F1 column. What you should do is set the X column to X, the Y column to Y, and the Z column to Z. So the Y column is still set to X.
Oops.
Yeah.
Oh, thank you.
Yeah,
And also,
sorry. If you click on, yeah, how to describe that? There's the center to data button. So in the top bar, you have solid color surface, and then to the right of surface, you have an icon with 4 arrows pointing outwards.
In the right top?
Yeah, so there's various toolbars on the top. Yeah, that one. So that zooms in on the data, so you are centered again.
Okay, thank you. Sorry, when I tried to add the auto filter, I couldn't find the auto filter.
Yeah, the Lonnie, you mean?
Yeah.
Yeah, that's correct. So this is a pipeline. So the Delaney only works on certain data. It does not work on the CSV files, but it does work on the table to points. So if you right click on the next one, that one,
I see.
it should
Okay,
be
thank you.
there. Yeah, Delaney 3D, I see it there.
Thank you.
Sure.
I'm going to stop.
Yeah. And then I'll share my screen again. Okay. And then here in the top, you can select what data you want to show. So I selected F2, which is this, this nice colored cube. And to change it into an egg, I'm going to apply the contour filter. And it automatically picks the value that's in between. So our value goes from 0 to 28.5. That's something that Paraview figures out automatically from the data. I press apply. Ooh. Oh, that makes perfect sense because I chose contour by F1 instead of F2. So if I look at F1, F1 changes color from the top left to the bottom right. So if I take a contour of that, the contour is going to be in the middle and it's going to be a plane. So I don't want that. I instead want to have a contour by F2. Then I can press the reload button here to reset the value to the middle. Then we get this big thing. So that still doesn't quite look like an egg. And the reason for that is that this value is too high. So we can change that to something lower, like 20. That almost fits. Then now it looks like an egg. And then we can change coloring. What did I choose? That one maybe? Yeah, I can choose cold and hot. And that gets me the egg in that I have in the slides. So yeah, the trick was to apply the contour filter and choose a proper value for the contour level. And then the coloring is by F1 using, what was it? Cold and hot. Yeah. Did that work for everyone?
Yarno,
Yeah.
I have kind of the opposite. I have like the volume block and then kind of a cutout in the middle, where I can see the egg. I haven't been able to get rid of the kind of hazy volume around the egg. Is that just taking off the eye of that? And that's it. Okay, I see.
Yeah, so I'm guessing it looks like
Okay, yeah, I got it.
like that. Sort of.
I had a different color scheme for the volume, but yes, it was basically that.
Yeah,
Okay,
exactly. So the eye symbol was
thank
on,
you.
so it's showing both at the same time.
Yeah, that was the problem I had. Thank you.
Sure. Okay. Yeah, that's what we did. So the other thing is warp by scalar, which is really nice for transforming 2D data into 3D data. So if I reset the session again, everything is blank again. There should be nothing in the pipeline browser. And I open the file 2d000.vtk, apply. Then I get 2D data. And you can, if you try to rotate that, instead of rotating, now it just moves it around. And that's because the view is set to 2D. So we want to change that to 3D. Then your data disappears. And you can get it back by either this one or that one. They currently do the same thing. And now it's rotating. And now we want to apply the warp to scalar. But before I show that, I'm going to let you try it yourself. So the data that you want to open, at first you want to reset everything, and then the data you want to open is 2d000.vtk. And then try to get the figure here on the right using the warp by scalar filter. Yeah, is everybody able to make that work? I'll go for it myself too, of course. So I'll just start from the beginning, reset. So open, and then for my data, 2d000.vtk. Apply to actually load it, and change the interaction mode to 3D. And then zoom back to the data. And then we're going to apply the warp to scalar, which is the last one in the list. And then press apply. And now we have a nice 3D shape, but it's really high. So I want to change the scale factor here down to something like 0.2. And now our 2D data has become 3D data. So yeah, that's it. Any questions for that? Okay. So we had in the beginning, when we played with the interface, we had multiple data next to each other. And you can actually link them together so that if you rotate one, the other one rotates in sync, which is really handy for showing multiple variables at the same time. So we're going to try that. We're going to now use the file diskout ref.ex2. So we're going to reset this again. Now it's all gone. Pipeline browser is empty again. And we're going to open disk out ref x2. And whoa, I guess I didn't say that, but you have to load all the data. By default, it doesn't load everything for this data set. So you have to click on the checkbox over here to load everything. Apply. And then we get a cylinder like that. Then we can split the screen, choose another render view, and make it visible as well. And then when you right-click in the screen on the right, you can choose link camera. So that's a right-click, link camera, and then you choose the other one. And now when you rotate, they rotate the same way. And you can change the left one to have temperature. Then you click on the right view and you select pressure. And now you can show both things at the same time. So yeah, just try that out. So to link the views, you have to right click in the screen in the render view. Oh, it looks like in the screen on the right, I had applied the clip filter, but we'll come to that later. Yeah, so did that work? Let's do it quickly again, now that you've played with the buttons. So I open disk out ref2 x2. I select all the data, so all the data files are loaded. I have my cylinder. I split the screen. I create another render view. And I click the eye symbol to show it again. Then I right click here, link camera, select the other view, and now they're linked together. And then I can apply different variables to each view. And you can do that as many times as you like, of course. You can make another one, show it there, and then link camera. Now they all move at the same time. So that is really handy if you want to show multiple things at the same time. Then we have the calculator. Calculator is also a very handy filter to have. It allows you to manipulate data right in Paraview. So if you have measured different quantities and they're in your data set, but there's another quantity that you can calculate from those quantities, you can do that. So the calculator lets you calculate new properties. Here I'm using the ideal gas law. So the pressure times the volume is the number of molecules times the gas constant times the temperature. So here our volume is constant. So let's just say that the density is roughly equal to or proportional to n times r. So we want to rewrite this formula so that the density, which is rho, which is roughly n times r, So that's P times V over T. We assume V is constant, so we can leave it out. So what we want is pressure over temperature. And we can put that in our calculator. So I'll just let you try that out. The calculator is up here. So try to apply that to your data. You may want to reset everything and start from new, so you get rid of all these linked cameras. And yeah, notice the button here on the bottom that says scalars. It allows you to select the data, so you don't have to type it. Yeah. Did anyone have any problems with that? Okay, let's just go for it. I'll reset everything, so restart afresh. Open the data file, which is still disk out ref x2. And make sure to load all the data. So we have our cylinder here with the entrance. And we're going to apply the calculate filter. And the result array name, we want to call it density. Or I guess I used n in the slides. And then we can, from the scalars, we have all our fields that are available. You can also choose the coordinates if you want that. But we'll use, forget what I said, pressure divided by temperature. Apply. And you can see it automatically gets applied. And you get a new field called density. That was not in your original data. If you look at the original data, you had pressure, temperature, and a bunch of chemicals. But there was no density. So now the calculator came along and it created an extra density field. And now you can just use that like any other variable. Okay, this is a really neat one. This is the stream tracer. And what it does is it just randomly generates a particle somewhere. And then it follows any vector data that you have in your data set. So in this particular data set, we have the velocity of the gas. So velocity is a 3D quantity, so it's a vector. So what this does is it takes that particle and then it follows all the arrows and it leaves a line behind. So you can see all the paths that a particle would follow. And it does that for many, many different particles. And it allows you to see all the flow lines inside of your data set. So here we're going to use it again on the same data set. and we're going to apply the stream tracer. So I'll just reset this thing, open the data, disk out with x2, take all the variables, apply, and then the stream tracer is this button here. Of course, you can also get it through the right click. So I'll let you try that. Okay, so let's try that out. I have my data here, and I'm going to apply the stream tracer, which is the button in the toolbar. And my seed type is going to be the point source. And I'm going to click apply. And you can see your streams, your streamlines are appearing here. They're still in the solid color, so we can change that to the velocity, V. And we can move the sphere to different positions. If you tried playing with that, get all these different lines. You can also change the number of points, so you can make it like 1,000, apply, gets a lot denser. So that's a bit too much, I guess. So let's put it back to 300. 100, I guess it was. And one thing I haven't mentioned yet is that now you can see the sphere in here. I'll just zoom in a bit. The sphere in there is the area is the surface on which the particles are generated. You don't generally want to show that inside of your visualization. So you can turn it off, and there's a checkbox called Show Sphere. If you click that, it disappears, and you're just left with the streamlines. And another neat thing you can do is you can turn back on the original data. Now everything is covered. But if you scroll down a bit, at some point you'll get to styling, which has opacity. If you change that, you can make it transparent. And now you can see where these streamlines are in relation to your object. So yeah, you can select disk out ref, so you can select your data set, and then you scroll down until you get to styling, and then you can play with opacity. I've noticed that this does not work on some installs. It might have something to do with what your graphics card is able to render. But yeah, for me it works, and for most people it should probably work. So, does anybody have any issues with that? You're all being very quiet. Okay, so there's one more filter I want to show, and then we'll get into the animation and exporting of all these screens, all these visualizations. And the next one I want to show you is the glyphs. So glyphs, I guess I should go back to the presentation. Glyphs are a way to show direction in data sets. So if you have vector data, you can add arrows to your visualization that shows what is pointing where. So we're going to try that now. And I have a different data set this time called half cylinder.vts. And we're going to apply the glyph filter to it. So we can reset. Everything is blank again. And we're going to open half cylinder.vts. And apply to load. And you get this empty thing. It has two data sets, density and velocity is going to be our vector field. So I want you to apply the glyph over here. And then try to reproduce what I have here on the right. Okay. So we have loaded our data and we apply the glyph. By default, the glyph type is already arrow. Orientation is by velocity, which is what we want. Scale error is already set to density, so that means it will scale with the density. So if I press apply, you can see my arrows appear here. I don't really want to scale with density, so I'm going to choose no scale array and apply. And now all the vectors are a constant length, independent of what the velocity is or what the density is. And I can make them a bit smaller. Like that. And I can change the color of them by going down to coloring and then choose, I forget what I chose, rainbow uniform. Yeah, that looks like it. So now you have arrows pointing everywhere. And they indicate the direction of flow or the direction of the velocity of the particles in, or whatever it is in this half cylinder. So with that, we're reaching our halfway point. So let's have a 15-minute break. So we'll be back at, let's see, I have to do math. I'll be back at 10:40. So I'll be back at 10:40. I'll see you in a bit. So we've explored all the filters that we have. Actually, I should check, is everybody back? You can type yes in the chat if you want. Ah, okay, great. Just checking. Yeah, so now we've explored the most common filters that there are, and now we can actually get to use them. So this is a bit more complicated exercise. I want you to use the filters that we've discussed, like clip and contour and all that stuff. And I want you to find the minimum of a file called stvol.nc. So it's a netcdf file. So for reading it, we need to get rid of that. Data is stvol.nc. And if you open it, we have to choose the netcdf reader. So not the CAM one, but netcdf reader. Apply. Surface. So that's the data that we have. And what I want you to do is I want you to find the global minimum, so where it's located. I don't need to know the value, just try to find it using the filters that we discussed before. So contour, clip, and all these others. Try to find the one that will give you the position of the global minimum. And I'll give you a few minutes for that. So yeah, did you manage to find it? So which filter did you use? You can unmute yourself or you can type it in the chat if you want. Contour. Yeah, that would be the best one. So we have our cube. We can apply the contour filter. If we apply it right away, we get something like that. But we can go much, much lower. So if our value range is going for -117 to something positive, so if we change this to 117, we got a point here. So if I turn back on ST-vol and I change the opacity, actually I can use a volume, I guess. Volume doesn't have opacity. Anyway, you can see it's in the lower corner there. So that's where the minimum is. Okay. Paraview can also be extended by plugins, and that lets you create much more, much more enhanced visualizations. So one of them is a line convolution plot, and it shows similar information as the streamlines, except that it shows it on the surface. So I'll show you how to do that. If you go to Tools and Manage Plugins, you get a whole lot of plugins that are already available. And you can add more if you want. These are the default ones. And I'm interested in Surface LIC, which is the line integral convolution, I guess. Anyway, I can select it and I can click on Load Selected, and then you can see it changes to Loaded. And if I reset this whole thing and I open my disk out ref again, which is the one we've been using before, with all the properties, and I'll cut it through the middle like that. And now I can choose Surface LIC as one of my options. That wasn't before, so that's now provided by the plugin. You can see you get an almost psychedelic thing there. Let me just turn off the plane so that's not in the way. And I can choose velocity. I can change the palette as well. Then I get something like that, which is almost like a Van Gogh painting. So that allows you to allows you to get more visualizations if you're not happy with the ones you've already got. You can add much more advanced ones. And I made this an exercise, but I think we should just go ahead and go to the exporting of images, because now that you have you know how to make visualizations, you want to output them and you want to put them in slides and all that stuff. So we can output images and we can output videos. So for images, there are four formats supported. So if, the BMP, PNG, JPEG, and TIFF. And PNG and TIFF are nice because they allow for a transparent background. So this arrow here, that's something from Paraview, and I exported it as a PNG with a transparent background. So now I can put it in my slides and I can put it on top of other things because it has a transparent background. So you can find this under File, Save Screenshot. I guess I should show this. So File, Save Screenshot, and then it asks me where to store it. So I'm just now in my home directory. I guess I'll just put it there. And this is lick, save. And then it's asking me for the resolution I want to save in. So the default value is the size of the screen as it currently is showing it to you. So these numbers will be different from you. I'll just change it to 800 by 600. And then you can change the background. So by default, it's using this grayish background, but you can change it to whatever you want. And you also have the options for a transparent background. So then the background is gone and you only have the actual data. And then you can put it in the slides and then it will save. Then the background of the slides will go through. Compression level, you don't have to worry about that. 5 is fine. And the higher the compression level, the longer it takes, but it doesn't take a long time. So, okay. And now my data is exported. And there it is. And you also notice that you'll have the color bar and the orientation. If you don't want that, you can turn it off. So you can go back to Paraview, and then at the bottom, you have orientation, axis, visibility. If I click that, here I had my axis, it's now disappearing. So now it's back. And the other thing is the color bar that we have over here. You can click on this thing here, which says show hide color legend. And as you can see, I can make it disappear. So then when I save the screenshot, let's just overwrite the one I had before, replace it, yes. And I'll take 800 by 600 again. And this time I'll do the transparent background. Okay. So then I reload my figure. And you can see the transparent is back as the same as it is in my program. And the color bar is gone and the orientation axis is gone. Another thing you can save is the state. So if you save the state, it saves all of your filters and orientations and everything you did in Paraview. It will save. But it will only save the state, so it won't save the data. So if you want to send this file to somebody else, you also need to send the data along. It's just the state file has a link to the data, not the actual data. So that's something to keep in mind. And the other thing that you have to keep in mind is that if you change something, Paraview will not ask, what do you want to save if you close? So if I have my figure here and I save the state, let's call it lick again. Then when I look at my home, I have my PVSM file, which is the Paraview state. I'm not sure what the M stands for. But then if I change something, I add something else, and then I close Paraview, it won't ask me if I want to save. So that's something you really need to take into account. Actually, I think it might do it on Windows, but it doesn't do it on Linux. Okay. So then we get to the animation. So animation is basically saving a lot of screenshots in quick succession. But Paraview allows you to export directly to a video, but it also allows you to export to a series of images. And if you export to a series of images, then you have more control over the video quality and also the video format. And you can also use it to make animated GIFs. So animated GIF is something you can put on your website. It starts playing automatically. And it's a great way to liven up the website with an example of the data that you're working in. So the way that works is, I guess I deleted my data. So let's just open data. Let's just take that one again. There's my data. Then when you go to View, Animation View, if you click that, you get an animation view here at the bottom. So it has a timeline, that's the number of frames. It also has start time and end time. And you can change things here. Actually, I'll get to that. Yes, okay. Sorry, I got a bit confused by this slide. So this is a bit of a horrible slide. This is just for your information. So when I said that you can export uh, to a series of images, this is what I mean when you can put it back together, uses FFmpeg, or you can use ImageMagick, which is another program that can do it. But you can, I'm just putting it here as an example if you want to do this. This is what you have to write on the command line to use FFmpeg to get a high quality 60 frames per second video. That's compatible with the Windows video player. So you have to add this color space. So this is more advanced usage, but like I said, you can also just export the video directly. For making animated GIFs, you have to do these two lines in succession. So the first one extracts the palette because GIFs GIFs can only have 256 colors. So you have to pick the right colors to make the best picture. That's what the first line does. And then the second line actually makes the animated GIF for you. So that's something that we're going to try now to animate. So here on the right, I have an animation of a slice. So every filter that you add, you can change the properties on the fly. So I'll just show you that. So we have the cylinder here, and I want to add a slice. So I add a slice, apply, and I have my slice here. I'll make it something prettier, so I'll use the velocity. And I will hide the plane, so you only have this data. So now I want to animate it. I want to make the slice go through the object. So here at the bottom, you see slice 1, which is the filter. Other options are the camera. You can even do Python and the data file itself. Those are less relevant. And here's slice 1. So slice 1 is the filter I want to animate. And the property I want to animate, you have various properties for the slice. The one I want is origin. Let's see. So 0 stands for X, 1 stands for Y, and 2 stands for Z. And if I look at my orientation thingy, I can see that my filter is going to go in the X direction. So I want to animate the X direction. So that's the origin. X direction is a 0 coordinate, so I select that one. And then I click the plus, and it gets added here. So now I can already press play. And I'm not even sure you can see it in Teams because it goes so fast, but it goes right through it. And that's because there are not enough frames. So I'm going to increase the number of frames to 100. Then I press enter. And if you notice, there are now more ticks in the timeline here. So now when I press play, it's a lot smoother. So I created 100 frames. I can also set it to loop. And I can still rotate while it's playing the animation. So you can find the right angle that you want to show this at. Okay, let's just stop that. So yeah, these up here are your time controls. I just started clicking them without saying what they were. So that is our video, our animation. And I will turn off the legend. I will turn off the orientation axis. So now we're just left with our animation without anything else. And then I can go to File, Save Animation, Slices, and I can choose FFmpeg AVI files. So that's the video format. Another option is the OGG video files. It's a different file format. AVI is the most common one, so that's one that YouTube will accept, for instance. Actually, it also accepts the other one, but just choose AVI. It will ask for the resolution again, so that's similar to what was asked in saving a screenshot. So I'll choose 800 by 600 again, which is a fairly low resolution for a video, but it's fast. Then it asks you for the frame rate. So the frame rate is how many frames per second. We've set this to 100 frames. So if I take 25 frames per second, that means my animation will take 4 seconds. So I press OK, and it exports all the images and creates one video file out of it. And here's my video, slices.avi. And there you go, it's a video now. Let's see, did I make that an exercise? Okay. So now I want you to do the same thing, but this time instead of a slice, I want you to use clip. And I want you to make it go up this time. So with up, I mean along the Z coordinates. And try to see if you can reproduce the video on the right there. And I'll give you about 5 minutes for that. And yeah, let me know if you have any questions about this, of course, either in the chat or unmute yourself.
Sorry, sir, we can't hear you.
Right, sorry. There's another mute button on the microphone itself that I had accidentally pressed. So even though Teams said I wasn't muted, yeah, sorry about that. I'll just go back to the beginning. I open the data file, data disk out ref, all the data, apply. So that's my my data, and I'll show the v, so the velocity, and then apply the clip filter. And the clip filter has to be in the Z direction because I want it to move up. So I choose the Z normal and I click apply. And I don't want to show the plane, so I just have my figure. And then here below I have clip 1, and then I can select what to animate. So I want my origin of the clip plane to move up. So there are 3 options there. 0 is X, 1 is Y, and 2 is Z. So I want the Z one, and then I press plus. And then when you press play, you get this really fast animation. So I'm going to add more frames. I make it 100, I press enter. So I get all these extra ticks here. Then I press play again, and then it's better. So one thing I didn't mention yet is that you can also change the range over which this animation runs. And what I mean with that is if you look in the animation view, you have your clip here. You can double click on the white area. So if I double click here, I get animation keyframes. And that allows me to change from what value to what value. So I can change this from -10 to 10. Oops, 10. So to edit these values, I need to double click them. So I press OK. And now you can see it runs from -10 to 10. And if I press play now, it goes all the way to the top. You can also change the interpolation. So if you double click on that, you can change it to exponential or sinusoid or just a step. So exponential, you can set all the parameters that you want. If I choose the base and I press play now, it goes slow and then it goes fast. I guess it's a bit hard to see. So, but ramp is the one I usually use. There's also time, which you can change as well. And that changes when the effect is supposed to start. So if I change this to 0.5, okay, you can see it turns gray here and then white here. So that means for the first half of the movie, nothing happens, and then the second half of the movie, then it changes. So you can see that if I press play, you got nothing, and then it grows. Oops, and that one. So the other thing that's very handy too is the camera paths. So often you have 3D data and you have a certain angle, but you want to show it from all sides. So the way to do that is to add a camera to the animation. And using the camera, you can place points in the space through which the camera has to fly. And you can also tell the camera where to point at. So on the right, I have an example camera path. It moves around the object. So I think I start here with a little arrow, and then I go through all of the points, and I move around the entire object. So let's just do that. I delete this one, So now my animation is gone. I'm no longer applying a clip. Actually, just reset. That's easier. I'm going to reset, open it, disk out ref again, all the data, apply, color by speed. Here we go. And now I can select camera. And there are various options. So there's orbit, there's follow path, there's follow data. You can also do some fancy interpolations. Orbit is the one that automatically creates the points in space for you, moving around the object as it's currently oriented. You can also create a path, and then you can put the points in manually. So you can create an entire path through space that the camera should fly to, and follow the data if you have animated data that you want to follow. For now, we'll use orbit. I press plus, and it gives me the orbit parameters. So in the center, so that's what the camera is looking at. The normal, that tells the camera what is up. So this is trail nearly 0, 0, 1. So the camera, up for the camera means along the Z direction. And then origin is where your camera starts. You can just use the default value. So you press OK, and your camera appears here. We increase the number of frames, so it goes at a reasonable speed. And then when we press play, you can see we move around. And once you've set in an orbit, it's fixed. I can move my I can move the orientation, but when I press play, it just resets back to the camera position that you set up the first place. So if you want to have a different angle, you have to delete it, move it around a bit, press the plus for camera orbit again, and then accept the new values. You'll notice that they're slightly different now. And then when I press play, it moves differently. And again, you can double click on the white area. And now it will show you the camera values. So if you drag this out of the way a bit, otherwise it's in front of the screen, you can double click on path. And then, oh, it's a bit small. Let's make it a bit bigger. We have camera position. And you can see, let's make that even bigger. You can see we have 7 points in our camera. So these are the X, Y, Z coordinates of the points that the camera moves through. So if I zoom out here, you can see there's, oops, that's not what I meant. Sorry, I pressed the wrong button there. But this leads into the next thing I was going to say. You can take these things and you can drag them around. And rotate, and you can make this go up, can this go down. So this is a really funky camera path I have right now. So that is now going to be the path the camera is going to follow. And to confirm this, I press OK, then OK again. And then if I press play, it will follow the new camera path, which is kind of wild. Let's just make it a bit slower by adding more frames. So yeah, this is a very flashy camera. So this allows you to really well, be the director. So you can zoom in on your data, you can move away. You can also remove points in the camera path. You can add more. You have a lot of flexibility. Let's just go back to the camera path, move it out of the way, double click on path, camera position. There's another option here called closed. If you click that, it's no longer closed. So if I zoom out a bit, you can see you have a start point and an end point. And that means you start somewhere, but you don't end at the same thing. Okay, okay. Press play. So we end at a different location than that we started. So the advantage of this is that you can start somewhere and end somewhere. But the advantage of having it closed means that you end up where you started, and that makes it ideal for looping. So, for instance, I guess I didn't have an example of that. But if you have a video that just loops over and over again, it helps a lot if you have if you end at the same place that you started at. And you can combine all these things. So you can have multiple things on your timeline. You can have them start and end at different spots. You can animate the camera first and then animate some sort of slice. So what I have here is I have two tracks in my timeline. I have the camera that orbits, and I have a slice which creates a slice. So let's just restart the video. So I rotate first, and then I start a slice while it's still rotating. So that's this overlap here. Let's see. So let's do that. So I have my thing here. I'll just delete my camera path. So what am I trying to recreate? I'm trying to recreate this. I have a cylinder that's split in half, so I have to use the clip filter. I have this slice that I'm moving up, so I have to use a slice filter. And I have a camera. So let's do that. So I select my data. I apply the clip. Apply. There we go. I remove the plane here. The other thing I want is a slice. I don't want the slice to work on my clip. I want it to work on the data. So I select the data and then the slice. And I want the slice to move up and down. So that's the Z normal. And I don't want to show the plane. Apply. And there it is. So those are the two filters I want. And now I need to add the animation. So I want to rotate around it with orbit. So I add that. And I don't want to rotate all the time, so I double click and I change the time from 0 to 1 to 0 to 0.6. Enter. So let's see what that does. So it rotates and then it stops. Then I want to add another thing, which is my slice. And my slice should go in the Z direction. So my origin 0 is X, 1 is Y, 2 is Z. And add that. Double click on that. And I want to start later. So I start at 0.4. And I want to go from -10 to 10. Enter. And then when I press play, you can see it rotates and the slice comes later. So that allows you to combine all these effects. And let's just see if I recreate the video. So it looks like I did only a half rotation, so I can do that too. Here's the camera. I double click on the camera. I go to the path and I look at the positions that my camera is moving through. Let's see. So I have a loop and I don't want a loop, so I remove the closed. And there are various points here that I want to delete. So I want to get rid of this one, which is the last one. I press the X to delete it. Oops, sorry, that was the wrong button. Cancel. Let's try that again. So I double click on the camera. I move this out of the way. Double click on path. I go to the camera positions. So the X actually means clear, so it removes all the points. What I meant to press was the minus. So I select the last point, which is this point here. I remove it. I will remove that one as well. I don't want it closed. Let's see, let's remove the very last one as well. So now we go through these points. So we start here and then we end kind of off the side. Okay, okay. Then we press play. I guess I got to the wrong side. But this is the general ID and we're getting close to the end. So I will let you try to do this one. I want you to animate the contour of the pressure and go from 300 to 600. And then once that's done, I want you to orbit around it, like in the video. So yeah, try to reproduce that. And I'll give you 5 minutes for that. So 11:31. Okay, that was 5 minutes. Let's see. So I'll just clear the data here. I will open disk out ref2 again. All the data. Color by pressure. Okay, so we were going to do the contour. And the contour was going to be, what did it say? Pressure, right? Yeah, animate a contour of pressure. So we're going to go to pressure. And then the value you put in here doesn't really matter, but I'll just press the refresh one so it shows something. And let's see, contour, ISO surfaces. And we go from 300 to 600. Let's see what it looks like. That's not rich. More frames. Did I do something wrong there? Oh, did I say the wrong fields? I'm so sorry. I meant to have temperature, not pressure. That was wrong in the slide. That should have been temperature. Sorry about that. Yeah, if you take temperature and you animate it from 300 to 600, you get this figure, the slowly deforming cup. And then we want to orbit around it using the camera orbit, and we accept the default parameters. Then when we press play, we move around it, but we wanted to do the contour first and then the camera. So we have to double click and change the ISO surface from 0 to 0.5 and the camera from 0.5 to 1. So then we have the contour here and the camera there. And then when we press play, we get that thing. Actually, the camera is moving pretty fast, so we can change that if we double click again and we change that to 0.4 and that to 0.4 as well. And we can make it slower by adding more frames. And now it looks like the video I had in the slides. Yeah, sorry about that. I put in press in the slides that should have been temp. So the other thing that Paraview does really well is it integrates with Python. So there are various ways to using Python in Paraview. You can open a shell inside of Paraview and directly work on the objects that you are shown in the display. You can use Python script as macros, so you can make an action that you do often, save that as a Python script, and then you have a button in Paraview that you can click to execute that macro. You can also make, programmable sources and programmable filters. So a programmable source lets you create an object based on Python code. So if you want to put in something that's not a sphere, or a cylinder, or a cone, or whatever, you want to make something yourself, you can use a programmable source. The other thing you can make is a programmable filter. So if you have a very custom filter that doesn't already exist in Paraview, you can make your own. The other thing you can do with Python is there's a program called pv-batch. So pv-batch takes a Python script as an argument and then does the visualization for you without ever opening Paraview itself. So you don't see anything, it all happens in the background. And that really makes it great for running on a server somewhere that's very powerful. So you submit the job with that script. That big powerful server does all the rendering, and after a while you check back and you should have a video waiting for you. So the way that looks like is under View Python shell. It appears under here. So this is a Python shell. You can print in your Python commands here, and it works. The other thing is the macros. They are up here. You can add new macros. They're based on Python scripts. And then you can edit them inline. The other thing is, if I go back to built-in sources, alphabetical, programmable source, you can type your script here, and you can choose what kind of data you want to create. So you can create a structured grid, or sorry, a rectilinear grid. So that's the grid that has points in one direction, points in another direction, points in another direction, and they're all equally distant. And then you can write your script here and generate it like that. And the same thing for your filter, programmable filter. It's the same. So it takes input data, your script edits it, and then outputs another data type. This is very advanced stuff. I'm just mentioning that it's here for if you know how to program Python, then that's a very useful skill to have, because then you can extend Paraviews in a lot of different ways. But Paraview is very helpful in finding what you should use for your Python, because you load the Paraview library in Python, but then you still need to know all the commands. So one very useful tool for that is the trace. So if I just delete that, actually I'm going to reset, because it's better to start from scratch. I can close that, I can close that. So under tools, you have an option called start trace. So if you click that, it will ask you what is your trace. The default is any property, so that's the one I would like. Click OK. And now Paraview is recording every action I do. It's recording it as a Python script. So I press open, I open my data file, open all the variables, apply, rotate it, I apply that one, rotate it again, move the plane, can save the screenshot. Hello. Default is fine. Okay, so now I've done a few things. So I can go to tools, and then I click stop trace. And then I get my script here. Zooming doesn't work here. So this is my script. It's a whole bunch of code, and that's all generated based on all the actions I took. So here's my loading of the data. So that's the data that I loaded. That's the variables I want to load. Then it sets up the camera. And these are all the options that you can set for your display. So it's coloring by different things. And if there's something here that you don't understand, I mean, I don't understand most of these things either. These are all default values. So that's what Paraview does in the background. You can also delete them and it'll just use the default values. Paraview puts them here and here in case you want to change them. So then we have, let's see, go down a bit more. So here's create a new clip when I created my clip filter. So that's how you create a new clip, what it applies to, what it clips, origin, then show it, and all options that you can set to the clip display again. And go down more. Here we have the time that I made a screenshot. So save screenshot, name of the file, name of the view you want to screenshot of, and the image resolution, and also the camera positions here. So this is useful because I can save the script. Save. Trial. Okay. And then I go to my command line. So there's my script trial.py. So that's what I just saved. And if you remember, I saved a screenshot as hello.png. So that's right here. So I will delete that file. It's gone now. And now I can run that script using Paraview. So pv batch, that's a program that runs Paraview scripts. Then the name of my script, enter. And now it does all the processing in the background without using the graphical component of Paraview. Oops, I accidentally deleted the file again. Let's just run it again. And there's my hello.png file again. And you can change things too. So this is my camera. And if I take this code, I copy it, I paste it, and then I can change the camera position. So here the set is 6.8. So let's just make it 68 point something. And then I save it as hello2. I save my script and I run it in pv batch. And I look at my files, and there's now an hello2.png. So I can open that one. Oh, I forgot to turn off the label there, so it's a bit strange. But if I look between hello that I saved from Paraview, and then the edit code where I put the camera way, way up, you can see I changed the camera angle. So you can probably guess that if you put this in a for loop and you save the screenshots in between, you can create a movie like that. So you have full control on the Python code, where the camera goes, what filters are applied and all that. So you can make even more complex animations using this. And the advantage of doing it from the command line is that you can submit it for remote rendering. So Compute Canada, every Canadian researcher has access to Compute Canada. They are really big compute clusters that are free to use for all of you. And you can submit these Python scripts to them and they will render the animation for you. So you can have a really high resolution, high quality video, do as complex things as you want, submit it to Compute Canada, they will do all the rendering for you. And at the end, you get your movie back and you don't have to stress your computer too much. It's all being done remotely. I put a link in here that tells you how to set it up. And if you have any questions about that, you can of course contact me as well. There's a lot more resources for getting started on Paraview because what I've just shown and practiced with you, it's just the beginning. You can actually get photorealistic animations in Paraview, so you can have objects that look like glass and there's lights going through it. So it really looks like a photorealistic scene. You can find more information about that in Paraview tutorials. Also, Westgrid has a lot of videos about how to use some more advanced features of Paraview, including that photorealistic rendering that I mentioned before. And I would highly recommend that you check them out as well. And of course, I'm here as well to help you with any of this stuff, or Compute Can in general, or programming or installing Surface and all that. If you need any help with that, you can contact me as well. You can use Topdesk or you can just email me directly. And that is the end of my presentation or workshop. We still have 15 minutes left and I had I sent you a link with a larger data set. So if you want, you can open that. So we'll close all that, reset, open data. Oh, that's not where I put it. So I sent you a file called vt2018.zip, and it contains all these files. So you have to expand it here, otherwise it thinks it's an animation. So I can select all these things. Oops, click, 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 click. I'm holding Control so I can. I'm holding Control so I can select more files. And there they all are. I click on Apply. And since this is a larger data set, you can see at the bottom here it's processing it. Processing. So this data set is a data set that was used for the 2018 Visualize This competition. It features a windmill. Oh, let me just zoom out a bit. I'm going to turn off air. And I'm going to zoom to data. Zoom out a bit. So these are a pair of vertical windmills. And the air is the airflow around it. So if I turn that on and I zoom out, that's the air volume. So this is a sample data set. I'll stick around for a bit and you can play with it. Or if you want to play with your own data set, that is fine too. And while you play with this, yeah, are there any questions about Paraview in general?
I don't know, Arya here.
Hi.
I text you a question.
Oh, I see. Sorry. The chat is always hard to see in Paraview. Sorry. Can you speak to what processes you would personally use this for your research? And I wonder if you do AutoCAD design or can also use it for data analysis. Yeah, so in my previous role as an academic, I worked in a group that did a lot of electrodynamical simulations. So they made simulations of lasers hitting microscopic objects, and we wanted to see how the light interacted. So I would use Paraview to visualize the beam coming in, how it hits the object, and I would show you the electric fields as they would propagate outwards towards the far field. So that's very domain specific. For this one that I'm showing now is it's airflow. So you can use that to analyze things. If I just put in the sheet here, I'm rescaling a bit. So now you can use this to analyze the airflow as it moves through the windmills. Let's just take it to V, I think. So yeah, that means that you can actually use this to analyze because it allows you to show exactly what the wind is doing. And if you have a visual model in your mind of what the data is supposed to show, that helps you a lot with analyzing. And your other question for AutoCAD design?
Thank you.
Yeah, sure. So it's not really for AutoCAD design, it's more for visualizing things that already exist rather than building your own. That's one neat thing you can do with Paraview is you can export the scene. And exporting the scene allows you to export the 3D objects as you visualize them. And then you can open them in other 3D programs. Blender, for instance. I'm not sure if AutoCAD would be able to read any of these. But these are various 3D formats that you can export to, and then other programs can read it in. And you can even animate it further with specialistic programs. yeah, I've never known any other questions. Yeah, I would recommend you play with this bigger data set, which is an actual data set that was used for competition, and it allow you to see how you can visualize stuff with Paraview. Of course, if you have your own data set, I would start with that. And if you need help loading in your data set, yeah, feel free to contact me. I'll put this recording, I'll process it, and I'll put it online. It will probably happen in the week or so. I'll send you an email when the video is up so you can review all this. And with that, I'd like to thank you. And yeah, good luck with Paraview. And let me know if you need any help with either Paraview or anything else computational related. Thank you.
Hi, sir. I still have a question.
Oh, sure. Go for it.
Yeah. So you mentioned that if you submit a script to Compute Canada, they can generate like video for you, right?
Yeah, correct.
Do they offer similar service for Visit?
Yeah, Visit is also available.
Okay.
So let's see if I go to the website. So docs.computecanada.ca. It's where all the documentation is. And if you search for Visit, it shows up, Visit. And it will tell you how to use it for remote rendering. So all the settings are there. And it's for the different classes as well. And if you need more help with that, I can help you with that as well.
Oh, sure. Thank you.
Sure.
Jarno, Arya again, just a quick question.
Yeah.
So if my data, the nature of the data, I'm wondering, should it be in a special, structure so that I can use this tool or not? Or let's say I have transaction data that are not shape particularly. Do you still see I can use this tool to analyze the data?
That might be complicated. Like Paraview can load in the spreadsheet data, like we've shown when we opened the CSV file, you got the spreadsheet data. And if there is any positional data in there that you could visualize, or if you can visualize certain attributes as position data. So for instance, if your transaction have a value that you could visualize as a position, then you could use it like that. But it depends on what the transactions show.
So the transaction should correspond with some sort of a 3D object.
Yeah.
So that, okay.
Yeah. I mean, you can create programmable sources, and then you can have your source dependent on data in your programming. Sorry, you can have programmable sources where the data depends on whatever you have in your transactions. That's the only way I think you would be able to visualize anything out of transactions.
Or maybe I can transform it with some sort of a mathematical function to have a presentation.
Yeah, exactly. Yeah.
Okay.
Yeah,
Thank
the
you.
calculator might be able to do that.
Hi, Yerna. One quick question. I think I made the mistake of trying to display this as a volume, and my computer doesn't seem to like that. So I'm not sure if it's crashed or it's just taking forever.
It's
Is there a
taking
way
forever.
to, yeah, is there a way to stop its current process?
No, you have to actually quit the program.
Okay, thank you.
Yep.
Thanks for the presentation as well.
Oh, yeah, sure.
Jarno.
Yeah.
On slide 34, it's the one with the Compute Canada. You know when you run the script pv bash, how many does this automatically allocate like a node? Like this, what does Mesa SWR AVX2? What does that flag do? Should I even bother? It's not important, I don't think.
No, so that line is there because Paraview has to know what to render to. So Compute Canada clusters, they don't have any monitors or whatever attached to them. So to make a display, it needs to display to something. And this line here, it tells it to use MISA, the software renderer. SWR means software renderer. AVX2 is the chip architecture. So this is something that Compute Canada tells you to use. So you don't really have to think about it, you just have to use it. And then for your other question, so this is the command line that does the rendering. To submit a job, you need to put it inside of a script. So I can quickly show you that as well. If I go to docs.computercan.ca, there is there's running jobs.
Like a SH script.
Yeah,
like,
exactly.
Okay.
So it looks like that. So it's an SH script. You put in some parameters that tell the scheduler how long it takes, what account. And then instead of echo hello world, you would use pv batch blah 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 and then the name of your script.
Okay. So do any of like MPI or OpenMP, could we use that? Could we do with, okay.
Yeah, you can use MPI. So let's see if I go to Paraview. Oops, Paraview. Does it say here? Yeah, this is for interactive.
Yeah, the link you gave is it like remote from your computer and interactive?
Yeah, so it's the running jobs one that you should use. There's an MPI job. So MPI job is the one. So srun MPI program, and then you would use srun and this MPI program, and then it would use multiple CPUs. So in this example, it would use 4 CPUs. So you would get your multi-threading going that way.
Okay, thank you.
Sure. Let's see, is any questions in the chat? No, that looks good. Okay, yeah, thanks once again. And yeah, if you any other additional questions, yeah, feel free to email me or contact me on Teams or whatever. Okay, thank you. Have a great day.